Today we're going over lesson 1.9, solving algebraic equations for a variable. So we're going to start off by solving some basic forms, but this time instead of getting an actual value for x or y, we're just going to solve for what would x equal no matter what y is in terms of value. So in this first one we've got 5x plus 7y equals 15. We treat x like it's the variable, and we treat everything else like it's a number. So even though we see that plus 7y is there, we're going to treat it like that's plus 14 plus 21. So we're going to subtract 7y from each side. And again, why subtracting? We're working PEMDAS, but we're going backwards, right? We're solving backwards through PEMDAS. And so we're start at adding and subtracting step, and we're working our way up because we're solving for a specific variable. So after we subtracted 7y from each side, 5x comes down, and we have 5x equals 15 minus 7y. Because of the variables, we cannot combine anything there. This is going to be 5x equals 15 minus 7y. And then we're still solving for x, so we're going to divide by 5 because 5 is multiplying there. So we're doing opposite operations like before. So our answer is going to be x equals 15 minus 7y divided by 5. Now you may realize that this can simplify a little further, but this is all we're looking for as an answer. This is all I'm looking for. Going on to the next problem. We have 1/4 a minus 5b equals 20, and we're solving for b. I like to underline or circle what we're solving for so that I can treat everything else besides that b as a normal number or a constant, right? So in this case, we have negative 5b we want by itself, so we're going to subtract 1/4 a from each side. Because again, since we're solving for b, we're always looking at the add, subtract steps first, right? And then we're going to look at multiply, divide. So once we bring everything left over down, we've got negative 5b equals 20 minus 1/4 a. Now we have multiplying going on here between negative 5 and b. Negative 5b is the same as negative 5 times b. So dividing all sides by negative 5. Now this one's going to look a little goofy because we have a fraction being divided by a number, right? So we've got b equals, and we're going to have to do a little more work here, right? 20 divided by negative 5 is going to give us what? That should give us a negative 4. And then now we have negative 1/4 a divided by negative 5. So again, how does that work? So extending the page here, divided by a negative 5, right? We're doing with fractions here. So what we end up doing is we flip it and it becomes multiplication. It's going to be times negative 1/5. Okay, so just finishing this part, we can't cancel anywhere. We've got negative 1 times negative 1. We're going to get positive 1a. 4 times 5 is 20. So our end answer is going to be b equals, as we said before, 20 divided by negative 5 is negative 4. And we've got plus 1/20a. That is your final answer in solving for b. We needed to simplify there because this is a complex fraction where we have a fraction and another fraction, right? Technically a fraction. And we'll learn how to deal with those at a later chapter, but at this point we're just going to flip it into, instead of doing dividing by negative 5, we're going to multiply by negative 1/5. Now here's a formula you may have seen before. This is perimeter equals 2 length plus 2 width, and we're solving for the length. Okay. So then we'll be able to look at our perimeter form and see where what it looks like if we just have length equals. So we are going to underline that L, and we're going to get rid of everything else. So we're going to subtract 2w from each side. Right? A reminder, we're going up PEMDAS. We're doing the add, subtract step. Now we have p minus 2w equals 2l. So now we're doing multiply, divide. Opposite of multiplying here is dividing, so we're dividing everything by 2. And we're going to rewrite this left to right, that we have L equals P, capital P, minus 2W all over 2. And there is your answer for length. To the next problem, we've got a lot of fractions. 4/5 w minus 3/10 x equals 3, and we're solving for w. Okay. So in this equation, right, as we've dealt with fractions before, we can look for what's the LCD. Whenever we've got a couple of fractions, we can look straight at the LCD and try to find it. So we've got 5 and 10. Well, this one's a little bit easier. 5 goes into 10, so our LCD is going to be 10. Okay, so what we're going to do is we're going to multiply every piece of the equation by 10. So 10 times 4/5 w minus 3/10 x times 10 equals 3 times 10. Okay, you do have to multiply every single piece by 10 to keep it equal. So even though 3 does not have a fraction, we still need to multiply. Now, what's left? We're going to now cancel. 5 goes into 10 2 times, and 5 has now become a 1. When the denominator is 1, we're done at that point. So 2 times 4 is 8, and we have 8w. The next part, negative 3/10 times 10. 10s are the same, so they just cancel, become a 1, and again we're done. 3x times 1 is just 3x, and the negative comes along. And lastly, equals 3 times 10. 3 times 10 is 30. So again, we're solving for w. We had to do that just to get it set up, and so we're solving for the w right there. So we're going to plus 3x to each side to get rid of it here. We're left with 8w equals 3x plus 30. And then lastly, we're going to divide both sides by 8. So everything on the left and the right gets divided by 8, and we're left with 3x plus 30 divided by 8. So w equals 3x plus 30 divided by 8. Moving on. Next up, we're going to start working on some word problems where they give us several pieces of the equation, but not the whole part, right? So here are some formulas we're going to be using. Most of these should be familiar. Distance equals rate times time, right? That's where it comes in. Temperature, Fahrenheit equals 9/5 Celsius plus 32. And as you see, area of a rectangle, triangle, circle, trapezoid, perimeter of a rectangle that we dealt with a couple of problems ago, and circumference of a circle, okay? So moving on, use the above formulas in the chart above to answer the following, and we're going to round to 2 decimals. So if the area of a triangle is 150 inches squared, that's area, I'm going to call it A for area, and the base is 20 centimeters, so we use B for base. What is the height? So we're going to solve for height, but we have area and base. So area of a triangle equals half base times height from the previous slide. Right? Area of a triangle right here. Half base times height. So we're going to fill in what we need here. Right now we know area is 150, so we're going to put 150 where A was, equals half. Base equals 20 here, so half times 20, and we don't know what height is, so we're going to leave that as an h. And now, just like 1617 lesson where we solved for x equals in a 1 and 2 step form, we're now just going to solve for h. It's the only variable there. So we're going to simplify on this side. Half of 20 is 10. And so now we have 150 equals 10h. Okay, since we're multiplying, we're going to divide by 10 on both sides away from the variable. And 150 divided by 10, we're going to wipe out the 0 at the end. And we end with h equals 15. Now it is a word problem, so we need a label. The label here is centimeter. So centimeters. Move on to the next problem. If the perimeter of a rectangle is 66 centimeters and the width is 12, what is the length? Now previously, we already solved for the length with this formula. If you hadn't, here's how we would solve it, right? We would plug in what we know. We have perimeter is 66. We have width is 12. And then length is what we're looking for. Okay? So we'd plug it in. 66 equals 2L plus 2 times 12. 2 times 12 is 24. So we have 2L plus 24 equals 66. And then we're going to subtract 24 from each side. So 2L comes down equals 6 minus 4 is 2. 6 minus 2 is 4. So 2 times the length is 42. We need to divide by 2. These will cancel out nicely. And we're going to get L equals 21. And again, going back up for our label this time, we've got L equals 21 centimeters. Okay. Now, in hindsight, we just did the formula for Lang. And if we had this formula handy at the beginning of the problem, we could have plugged in the value and solved that way. Right? So L equals P minus 2W over 2. And so P minus 2W over 2, we could have filled in the values and still solved, right? We have 66 and 12. So 66 minus 2 times 12 divided by 2 would give us the length, and we could just solve this and would have gotten the same answer. 66 minus 24 gives us 42 divided by 2, and 21 equals L. And again, it was centimeters. So we also could have done it that way, having already solved for the variable L with the perimeter. Lastly, 7. The area of a trapezoid is 110 feet squared, the height is 20 feet squared, and one base is 5 feet squared. Right, I like to label these so I can tell which variable I have. It said one base, we'll just call that base 1, b sub 1. What is the length of the other base? Now again, going back to your area formulas, the area of a triangle is half height, parentheses, times b1 plus b2. Okay? And we know what a, height, and b1 is, so we're going to be solving for b2. So we're going to plug it all in. 110 equals half of 20 times 5 plus b2. We don't know what the second base is. And so now we're going to do a little bit of multiplying here to simplify. 2 goes into 20 10 times. We've got 110 equals 10 times 5 plus b2. Okay, b sub 2. Now we're going to distribute to get rid of the parentheses, and we're going to be left with 110 equals 50 plus 10 times b2. Recall that 10 goes into both pieces. Okay, subtracting 50 from each side, we're going to be left with 60 equals 10b2, b sub 2, and then divided by 10 on each side, we get rid of 0 at the end. 60 divided by 10 gives you 6. So the base 2 equals 6. And again, don't forget our labels. The label were feet, 6 feet. That concludes this lesson. The homework is already on Moodle, so check out Moodle. And if you don't have that, here's the numbers, page 35, 1, 4, 6, 8, 11 through 13, 15, 16, and 17.